Hello everyone, this session is regarding Thevenin's theorem. Here we are going to discuss some problems with dependent sources. So if the given network contains both independent and dependent sources, we can use this equation for finding out Thevenin resistance RTH. RTH is equal to VTH divided by IN, where VTH is the Thevenin voltage and IN is the short circuit current which would flow in a short circuit placed across A and B. And dependent sources are active all the times. And if the network contains only dependent sources, RTH is equal to V by I, where V is a known voltage applied across A and B, I is current through the path AB. So if the given network have both independent and dependent sources, we can use this equation, where IN is short circuit current between A and B. And if the given network contains only dependent sources, we can use this equation where V is a known voltage applied across A and B and I is the current through the path AB. Let's start with an example. Obtain the Thevenin equivalent network for the given circuit. First step is to find out Thevenin voltage VTH. In order to find out VTH, VTH is the voltage between terminals A and B. And from the figure itself, it is clear that the current I1 flows through this path. It will not flow to this path because here we are having an open circuit. So the entire current I1 will flow like this. So from the diagram, we can write I1 is equal to minus 2 into I1. And we will get the equation for I1 as I1 is equal to 0. Then write the VTH equation. In order to write the VTH equation, apply KVL, Kirchhoff's voltage law, to this loop. This voltage between A and B is VTH. So we will get the equation as 8 minus 4 into I1 minus VTH is equal to 0. From here we can write VTH is equal to 8 volt. The next step is to find out current IN. IN is the short circuit current through a short circuit path between A and B. So redraw the circuit and short circuit the terminals A and B, and current through that short circuit is marked as IN. Now our aim is to find this IN. In order to find out IN, two mesh currents I1 and I2 are marked like this. And from the diagram it is clear that I1 and I2 are in opposite directions. So we can write minus I1 plus I2 is equal to 2I1. From here, we will get the equation like this. Mark it as equation number 1. 3I1 minus I2 is equal to 0. Equation number 1. Then apply KVL to the outer mesh. When applying KVL to this outer mesh, we can write the equation like this. 8 minus 4I1. Here this voltage is 0. That is equal to 0. So 8 minus 4I1 is equal to 0. From here, we will get the value for I1 as 2. Substitute this value of I1 here. Then we will get the value for I2 also. So applying that equation, we got the value for I2 as I2 is equal to 6. And from this diagram, it is clear that IN is exactly same as I2. So we can write IN is equal to I2 is equal to 6 amperes. The next step is to find RTH. According to the equation, RTH is equal to VTH divided by N. That is equal to 8 by 6. That is equal to 1.33 ohm. Now let's draw the Thevenin equivalent circuit with VTH as 8 volt and series resistor RTH is equal to 1.33 ohms. Then let's move to the next question. Find the Thevenin equivalent network. So first step is calculation of VTH. In order to find out VTH, a loop current I1 is considered like this. And from the circuit, it is clear that Vx and VTH are same. Vx is given as voltage between A and B. And Thevenin voltage is also the voltage between A and B. So we can write Vx is equal to VTH. And from the circuit we can write I1 is equal to minus 0.1 Vx. I1 in downward direction, 0.1 Vx in upward direction. So we can write I1 is equal to minus 0.1 into Vx. Now writing KVL equation for this outer loop. When we can write the equation as 4 minus 2 I1 minus Vx is equal to 0. So we will get the equation like this. And I1 is minus 0.1 into Vx. Substitute the value for I1. Upon solving, we will get VTH is equal to 5 volt. Then calculation of IN. In order to calculate IN, short circuit the terminals A and B. We will get the circuit diagram like this. Then from this diagram, it is clear that there is a short circuit between terminals A and B. So potential difference between A and B is 0. So we can write Vx is equal to 0. As Vx is equal to 0, 0.1 into Vx is also 0. So we can omit this dependent source. Once again, Vx is equal to 0 because here we are having a short circuit. As Vx is equal to 0, 0.1 into Vx is also 0. So we can omit this dependent source and redraw the circuit. Then we will get the value for IN as IN is equal to 4 divided by 2 plus 3. Then calculation of RTH. VTH divided by IN. We will get it as 6.25 ohm. Then draw the Thevenin equivalent circuit with VTH 5 ohm and RTH 6.25 ohms. VTH 5 volt and RTH 6.25 ohms. Now moving to the next problem. Obtain Thevenin equivalent network for the terminals A and B. In order to calculate VTH, draw the circuit like this, and mesh current I1 is marked. From this circuit, it is clear that I1 is equal to minus 2 IA. I1 in downwards direction, 2 ampere upwards is the net current. So we can write I1 is equal to minus 2 ampere. Then applying KVL2 here. By applying KVL, we can write 2 minus 2 into I1 is equal to Vx. This is the voltage Vx. This voltage will be equal to 2 minus voltage drop across this resistor. That will be 2 minus 2 into I1. So Vx is equal to 2 minus 2 into I1. Substitute the value for I1. I1 is equal to minus 2. So we will get Vx is equal to 6 volt. Now consider the outer mesh. Apply KVL to the outer mesh. Then we can write 2 minus 2 I1 minus 1 into 0 because this current is 0 plus 4 into Vx minus VTH equal to 0. So we will get this minus VTH. So we will get Vx is equal to 2I1 minus 2 plus VTH. From here we will get the value for VTH as 30 volt. Then calculation of IN. Now to calculate IN, short circuit A and B, we will get the circuit like this. From here we can write minus I1 plus I2 is equal to 2 ampere. Then Vx is equal to 2 minus 2 into I1. This is 2 volt. Voltage drop across the resistor is 2 into I1. So 2 minus 2 I1 is equal to Vx. We got the equations 1 and 2. Then applying KVL to this loop, we can write the equation as 2 minus 2 I1 minus I2 plus 4 Vx is equal to 0. From that, we can write 10 I1 plus I2 is equal to 10. Now solve the equations 1, 2 and 3. We will get the equation values for I1, I2 and IN. IN is I2 that is equal to 2.73 amperes. Then calculation of RTH, VTH by IN. 10.98 ohms. Then draw the Thevenin equivalent circuit with VTH is equal to 30 volt and RTH is equal to 10.98 ohms. The next question, find the Thevenin equivalent network at AB. Since the network does not contain independent sources, VTH is equal to 0, IN is equal to 0. Here in this circuit, only dependent source is there. No independent sources are present. So, if no independent sources are present in the circuit, Thevenin voltage between A and B will be 0. Then IN is also 0. But the RTH can be calculated by applying a known voltage source of 1 volt at A and B. In order to find out RTH, we have to place a known voltage source between terminals A and B. A known voltage source, and magnitude of that voltage source is assumed to be 1 volt. Now find the value of current I. In order to find I, apply KVL to mesh 1. While applying KVL to mesh 1, minus 4Vx minus 2I1 minus 5 into I1 minus I2 equal to 0. And one more thing, Vx. Vx is this voltage. Vx is equal to 5 into I1 minus I2. Vx is voltage across 5 ohm resistor. That will be equal to this current into 5. So Vx is equal to 5 into I1 minus I2. Substitute this value for Vx here. Then we will get the equation like this. Then apply KVL to the second mesh. While applying KVL to the second mesh, we will get the equation like this. Minus 5 into I2 minus I1 minus 4 into I2 minus 1 is equal to 0. While separating terms for I1 and I2, we will get the equation like this. Now solving equations 1 and 2, we will get the value for I2 as 0.23 amperes. And RTH is V divided by I. That is equal to 1, V is 1 volt, 1 divided by I. I is this current. We got I2 is equal to minus 0.23. So we can write I is equal to 0.23. Then draw the Thevenin equivalent circuit with VTH is equal to 0 volt and RTH as 4.35 ohms. Okay, thank you.